Welcome back to another exciting day of Algebra 2. Today we are doing another set of review topics. The first one we're going to look at are domain restrictions. So the two things that will restrict your domain when all you're given is the function and not the graph is anything that would cause you to divide by 0 or anything that would cause you to take the square root of a negative number. So if we are worried about either of those cases, we have to figure out what x values need to be eliminated from the domain. Now, if we don't have x in the denominator and we don't have x inside the radical, then we have no domain restrictions and our domain is going to be all real numbers. So we are going to use that information to state the domain for each of these functions in interval and inequality notation. So on this first one, I don't have x in a denominator and I don't have a square root, so I have none, no domain restrictions. So in interval notation, my domain would be negative infinity to positive infinity. Remember, infinity always gets parentheses. And in inequality notation, we could just say all real numbers. Remember, we have this symbol that means that in shorthand. On the second function, again, no x in the denominator and no square root, so I have no domain restrictions. So this will also just be negative infinity to positive infinity and all real numbers. Now, when I get to number 3, I've got x in a denominator, so I am worried about restriction type number 1, something that would cause me to divide by 0. So if x minus 5 were to become 0, that would mean x was 5. So I need to eliminate 5 from my domain. So in interval notation, we'll say from negative infinity to 5, union 5 to infinity. And in inequality notation, we could just say that x does not equal 5. On number 4, I have restriction type number 2 because I've got x inside of a radical. So I need x minus 7 to stay greater than negative value, so that means greater than 0, but it could also be equal to 0. I can take the square root of 0. If you type that into your calculator, it will just spit out 0. So what will keep this true? Well, if I get the x by itself by adding 7, that means x has to stay greater than or equal to 7. So there is my inequality notation for number 4. To convert that to interval notation, I will say bracket 7, because it's underlined, to positive infinity, and again, infinity always gets a parentheses. Okay, on to number 5. Again, I have x inside of my denominator, so I'm worried about type number 1 restriction. I don't want to divide by 0. And in this case, negative 3 is the input that would cause that to happen. So our domain will be from negative infinity to negative 3, and then from negative 3 to positive infinity, all with parentheses. And for my inequality notation, I will just say that x cannot equal negative 3. On 6, again, this is a type 2 restriction. I need to make sure that 5 minus 2x stays greater than or equal to 0. So to figure out my domain, I'm just going to solve this inequality. First, I will subtract 5, then divide everything by negative 2. So for my inequality notation, I will get that x has to be less than or equal to 5 halves. It switched directions because I divided both sides by negative. So that's my inequality notation. To go to interval notation, this is all values less than 5 halves. So that's going to be from negative infinity to 5 over 2. And it gets a square bracket because our inequality is underlined. We get to include it. On 7, no domain restrictions here. We're not dividing anything with x and we don't have a square root. So my domain is again going to be negative infinity to positive infinity, or all real numbers. And then last but not least, number 8. I have a radical in my denominator, so this has both types of restrictions. Sorry about that interruption. So this looks very similar to number 4, except the difference is while the square root of x minus 7 could be 0, when it's in my denominator, it no longer can be 0. So instead of this being greater than or equal to 0, it has to remain greater than 0. I can no longer include 7 in my domain. So for inequality notation, x would be greater than 7, and for our interval notation, we would do parentheses 7 to infinity. Okay, switching gears a little bit, we are now going to calculate slope. If you are rusty on math, the formula we use m to represent slope is y2 minus y1 over x2 minus x1. And to calculate that, we just need to find 2 points on our graph. So on the first one here, I could take negative 4, negative 2, and 0, negative 4. To calculate my slope, that would be negative 4 minus negative 2 divided by 0 minus negative 4. Remember, when you have double negatives, that becomes plus positive. So negative 4 plus 2, that is negative 2. 0 plus 4 is 4. So my final result for my slope here is negative 1/2, which as a decimal would be negative 0.5. And I'm bringing up decimals because when we get to the back side with applications, we will have some decimals. Moving on to the second graph, I've got a point here at negative 2, negative 1, and another one at 0, 4. So for my slope, I'm going to do 4 minus negative 1 over 0 minus negative 2. Again, both of those become plus positive. So we have 5 over 2, or 2.5. Now, keeping all of that in mind, we are going to use what we now know about slope to interpret rate of change. Remember, rate of change just means slope. So first, we've got these two guys that have competing taxi cab companies, Jackson and Freddie. They both charge a one-time pickup fee for every ride, as well as a charge for each mile traveled. So if you're thinking about a linear equation, y equals mx plus b, remember, m is your slope and b is your y-intercept. In this case, with our taxi cab company, the one-time pickup fee is going to be our y-intercept, and the charge per mile is going to be our slope. So in order to compare these two companies, we are first going to have to derive our linear function using our given information. So Jackson charges $3.50 for his pickup fee and $1.30 per mile. Right away, that tells me my y-intercept and my slope. So we'll call Jackson's function j of x. That is going to be $1.30x plus $3.50. And in this case, x is representing the number of miles I'm traveling in my taxi cab. For Freddie, it's not so easy. I'm given a table, so I have to first calculate my slope using any 2 points. I'm just going to go with the first two because I do like smaller numbers. I'm less likely to make a mistake. So 43.50 minus 22.50 is 21. 20 minus 10 is 10. So this is 210. I'm going out to that hundredths place because we're talking about money, and that's typically how money is handled. We go to dollars and cents. So let's do F for Freddie. We know that his slope or rate per mile is $2.10. Now I just need to find his pickup fee, the y-intercept. The way you can do that is using your slope-intercept form. Substitute your slope and one of your xy pairs to solve for b. Again, you can pick any of these xy pairs in the table. I'm going to go with the first one because I like to keep the numbers smaller. So 2250 is going to be equal to my slope, we just calculated it, times my x value 10 plus b. So 210 times 10 is 21. So to get b, I'm going to subtract 21 on both sides, and I get that b is $1.50. So his pickup fee is $1.50. Now, when you just look at these, you might think one way or the other, well, Freddie has a lower pickup fee, but his mile fee is higher. So which taxi cab company is more efficient is going to depend on how far you're going. So if I'm taking a 40-mile ride to the airport, in order to accurately compare those, I would want to find j of 40 and f of 40. So you would plug in both of those into your function. So $1.30 times 40 plus the $3.50 pickup fee. It's going to be $55.50 for Jackson to take me to the airport, or $85.50 for Freddie to take me to the airport. Now, because Freddie's pickup fee is lower, at some point in time, some distance, it would be cheaper to take Freddie, and we could determine that if we used a graph, for example. So you could graph these two, find where they intersect. That would be like your break-even point. And then beyond that, Jackson's going to be your cheaper option. This explanation box is used for you to just kind of summarize everything we talked about just now in a couple complete sentences, so you can pause this and take care of that. Moving on, we've got 3 friends that are saving different amounts of money each week. Marie starts with $35 and adds $10 every week. Again, this is representative of our y-intercept and our slope. So I'm going to go with m of x for Marie. I know she's adding $10 every week, and she's starting with $35. In this case, our x's are representing the number of weeks. Then moving on to Jacob, we are given this graph, and right away on that graph I can see that my y-intercept is 40. I just need to figure out what the slope is, and it gives us 2 points, so 165 minus 40 over 10 minus 0. 125 over 10 is 12.5, and I'm going to take it to that hundredths place because we're talking about money. So Jacob is adding $12.50 every week. Now lastly, with Lainey, we are given a table, so kind of like what I had to do with Freddie's Taxi Cab Company, I first need to find the slope between 2 points. So Lainey is adding $7.50 to her bank account or piggy bank every week, and I just need to now figure out how much she started with. So again, remember y equals mx plus b. This is my slope. I'm going to use the first xy pair just to keep my numbers as small as possible. So 7.5 times 4 is 30. Subtract. And we get that our b value is 5. So Lainey started with $5. So in 1 year, which friend would have saved the most money? Now, if you're looking at all of these intercepts and slopes, Jacob starts with the most and is contributing the most every week. So that would be a good guess. But for the sake of it, remember there are 52 weeks in a year. Let's find M of 52, J of 52, and L of 52. So Marie will have $555. Jacob will have $690. And Lainey will have $395. So as predicted, Jacob is going to be the winner because of, as we stated, he's starting with the most and adding the most every week. So again, you could write a couple complete sentences here talking about those predictions and maybe even say something about the comparison between Marie and Lainey and would they ever intersect at some point on our graph. All right, that is all I have for you on day 2 of review. Stay tuned for our new material next time.